Hello. So let's try to do another example. And so let's look at this one. So we want to make a conjecture for the natural numbers k for which 3 to the k plus 4 to the k is less than or equal to 5 to the k. And then we want to prove our conjecture using induction. So this one is a little different in that they don't give us a base case. They don't tell us what it is. We have to figure it out ourselves. So let's jump in. Just like in the previous examples, let's talk about what the predicate even is. So we want to write down P of k, our predicate. And our predicate is the claim that 3 to the k plus 4 to the k is less than or equal to 5 to the k. And we have to figure out for which k values that's true. And then we're going to prove it. So let's just try some k values. Let's try k is equal to 0. And the predicate for that one is going to be 3 to the 0 plus 4 to the 0 is less than or equal to question mark 5 to the 0. All right. So 3 to the 0 is 1, 4 to the 0 is 1. This is 1 plus 1. This is equal to 2. 5 to the 0 is just 1. And is 2 less than or equal to 1? No, it's not. So that's not what we're talking about. So it's not k is equal to 0. So let's try 1. So the predicate on 1, this is going to be 3 to the 1 plus 4 to the 1. And then our claim is that that's less than or equal to question mark 5 to the 1. And 3 to the 1 is 3. 4 to the 1 is 4. So this is 3 plus 4. This is equal to 7. 5 to the 1 is just 5. And 7, is 7 less than or equal to 5? No, it is not. So this is an x, and that one's not true. Let's try 2. K is equal to 2. So P of 2. So this is the claim that 3 squared plus 4 squared is less than or equal to question mark 5 squared. So 5 squared is going to be equal to 25. And 3 squared is 9. 4 squared is 16. And so this is going to be 25 as well. Is 25 less than or equal to 25? It is. And so this one is true. And let's try maybe one more. Let's do k is equal to 3. So this is the claim that 3 cubed plus 4 cubed is less than or equal to question mark 5 cubed. So 3 cubed is 27. 4 cubed is 64. And 27 plus 64 is going to be 91. And is that less than or equal to 5 cubed? 5 cubed is going to be 125. It's going to be 25 times 5. So this is 125. And that is true. Nice. So it looks like the k values are going to be everything greater than or equal to 2. We don't know that. That's kind of our guess. So that's just where we're going to start. And so let's do that. Let's write it down. So our base case is going to be k is equal to 2. And so we're going to write down 3 squared plus 4 squared is equal to 9 plus 16 is equal to 25. And that's less than or equal to 5 squared, which is equal to 25. That's a true statement. And so we say good. Our inductive hypothesis is what we've been doing in all of the examples. So we just say assume P of K is true for some K greater than or equal to our base case, which is 2. And so i.e. assume 3 to the K plus 4 to the K is less than or equal to 5 to the K for some K greater than or equal to 2. And so then let's write down the induction step. So just like in the previous examples, we're just going to write down consider K plus 1. And again, just like in the previous examples, we're going to write down one side of the predicate for the K plus first term, and then we want to end up at the other side of the predicate. So we want to write down 3, that's what we're looking, 3 to the K plus 1 plus 4 to the K plus 1. And then eventually, dot, 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 we want this to be less than or equal to dot, 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 5 to the K plus 1. And so just like in the previous example that I mentioned, everything that we've written down so far is formulaic. We wrote down the base case. After we did our kind of game planning on the previous page, we wrote down the base case, we wrote down the inductive hypothesis, and then we wrote down consider K plus 1 and the left-hand side of the predicate for the K plus first case. And then again, just like in the previous example, all the magic, everything that we contribute to the proof is going to be between here and here. All of this other stuff that we've written down is formulaic. You should be able to write it down without really thinking all that much. So let's fill it in. Let's think about it. And it's not always going to be clear like what exactly you need to do. And so yeah, let's just kind of jump into it. So one thing that we do know is that we need to use the inductive hypothesis. So eventually we need to write down something involving 3 to the K plus 4 to the K so that we can use the inductive hypothesis. So what I'm going to do is I'm going to try to kind of rewrite 3 to the K plus 1 plus 4 to the K plus 1 as 3 to the K plus 4 to the K. So the first thing I'm going to do is I'm going to pull out I'm going to rewrite this. So this is 3 times 3 to the K plus 4 times 4 to the K. And then what I'm going to do is I'm going to say, well, this is less than or equal to 4 times 3 to the K plus 4 times 4 to the K. And so why I did that was that I did it for 2 reasons. One is that, well, 4 is greater than or equal to 3, so this inequality does in fact hold because we're multiplying by something bigger on this side, the 3 to the K term, so it's going to be bigger. So this whole sum over here is going to be bigger. And then another reason to do that is I want to be able to factor out something so that we just have a number times 3 to the K plus 4 to the K so that we can use our inductive hypothesis. So this is going to be 4 times 3 to the K plus 4 to the K. Okay, so that's good. And then we're going to say that this term over here, the one we just wrote down, using the inductive hypothesis, this is going to be less than or equal to 4 times 5 to the K. Because by the inductive hypothesis, 3 to the K plus 4 to the K is less than or equal to 5 to the K. So we're just using our inductive hypothesis to go from here to here. But then we're going to do one last trick. 4 is less than or equal to 5. So this is less than, or well, in particular it's less than, but this is less than or equal to 5 times 5 to the k. So 4 is less than or equal to 5. Well, it's strictly less than, but 4 is less than or equal to 5. So we can write down 4 times 5 to the k is less than or equal to 5 times 5 to the k. And so then this is equal to 5 to the k plus 1. And now we're done. So we have a string of inequalities where we say 3 to the k plus 1 plus 4 to the k plus 1 is less than or equal to, well, less than or equal to 5 to the k plus 1. Nice. Nice, nice, nice. And so we're done. So then, because we have our base case, we have our inductive hypothesis, and then we showed that if, you know, the statement is true for the kth value, it's true for the k plus first value, then it's true for all k greater than or equal to the base case, which is 2. However, I want to point out, so when you guys are doing these, or when you all are doing these inductive proofs, like, you know, I am a teacher and I've kind of prepared for this lesson, so I know like what the steps are going to be. And if you're thinking like, wow, I never would have thought of that, thought to do it that way. One thing that I want to say is that there's a bunch of different ways to do these different proofs. Like you did not like have to do it in this specific way, where, you know, you pull out a 3 and then you change it to a 4 and then you pull out the 4. Like, you know, there are other steps to go from 3 to the k plus 1 plus 4 to the k plus 1 is less than or equal to 5 to the k plus 1. All you need is that the steps that you use are mathematically correct, so you can't write down anything wrong, and then you end up with the conclusion that you want. So that's one thing, and then another thing is that, yeah, it's kind of hard. It's kind of hard to come up with, like, you know, steps to go in between there, and proofs are kind of hard. And so don't get discouraged. You know, it was hard for me too back in the day when I was first starting out, and now it's like, you know, quite a bit easier. And so just keep working. And then again, another thing that I mentioned earlier is that, you know, 80% of this proof we wrote down, right? It was formulaic. This is formulaic, and then writing down this, and then this was formulaic. The only hard part was all the stuff, like this stuff in between right here. And so if you're ever stuck on a proof, you know, like using mathematical induction, just write down like all the stuff that you know. And then while you're writing down all the stuff that you know, think about like, you know, how you might try to go in between. So sweet. So let's finish out this proof. So we say, therefore, 4 to the, well, therefore 3 to the k plus 4 to the k is less than or equal to 5 to the k for all k greater than or equal to 2. Sweet.